Hi guys, welcome back sa ating video part 2 for permeability. So let's have an example. So we have here example 7.1. Refer to the constant head permeability test arranged shown in figure 7.5. So ito yun. A test gives the values of the length of 30 centimeter. So we have a length of 30 centimeter. We have an area of the specimen of 177 centimeters squared. And we have a constant head difference of 50 centimeter. So the water collected is 350 centimeter cube at 5 minutes. So since this is a constant head permeability test, ito lang naman yung gagamitin nating equation. Just simply copy that, then paste it here. Hydraulic conductivity is equivalent to flow times the length divided by the area times the head divided times time. So, yung Q natin, it would be 350 centimeter cube divided by 5 minutes. Okay? Dito kasi rekta na, no? But let's simplify it. So, 350 divided by 5, that would be 70. So, Q is 70 centimeter cube per minute times the length. Ano yung length natin? 30 centimeter. Then, we have the area of 177. Then, we have the head of 50. And the time of 60 second per 1 minute. Okay, dito kasi dinirekta na. So, 350 divided by 5. Tapos, ginawang seconds. Therefore, the hydraulic conductivity is 3.95 times 10 raised to negative 3 centimeter per second. Next would be, for a falling head permeability test, the following values are given. So we have the length of the specimen. The length of the specimen, ito yon. Area of the soil specimen. This is the area of the soil specimen. The area of the standpipe. So the area of the standpipe, ito yon. Yung bilog. Then, we have difference times 0 at 500 time 180 at 300. So, this is time 0, 500, time 180 at 300. Okay? So, since it is a falling head test, we simply copy this equation. 2.303 AL over 80 log base 10 H1 over H2. So 2.303 AL over 80 log base 10 H1 over H2. Yung small l, that is the area of the standpipe. Small a, area of the standpipe, that is 40 times the length of 200 divided by area of the specimen, yung capital A, that is 1,000, times the time of 180 seconds. Log base 10, from 500, bumaba siya sa 300. Therefore, your hydraulic conductivity is 2.27 times 10 raised to negative 2 cm per second. Next, example number 3. The hydraulic conductivity of a clay soil is 4 times 10 raised to negative 7 cm per second. The viscosity of water is at 25 degrees Celsius is 0.0911 times 10 raised to negative 4 gram second per centimeter squared. So we have here the hydraulic conductivity, the viscosity. Therefore, we need to solve for the permeability, absolute permeability. So this is for the absolute permeability. K is equivalent to the unit weight of water divided by the viscosity times the absolute permeability. So copy that equation, place it here. So 4 times 10 raised to negative 7, that is K, is equivalent to, since it is in centimeter, convert natin yung kilonewton per cubic meter, gawin natin in centimeter. So that is 1 gram per cubic centimeter divided by the viscosity, and that this is our viscosity, 0.0911 times 10 raised to negative 4 times the absolute permeability. Shift solve, your value is 0.3644 times 10 raised to negative 11 centimeter squared. Next, if you have this kind of problem, you have an impervious material beneath a permeable layer and a groundwater at the top, then we should analyze it this way. So the difference in head, so this is 0.1 to 0.2, this is delta H. This is delta H here, so tangent alpha, no, that is alpha rather. Tangent alpha is equivalent to delta H over S. So delta H is equivalent to S tangent theta. So cosine alpha is equivalent to adjacent over hypotenuse. So this is simple trigonometric function. Okay? So this is a simple trigonometric function. So if this is S, tapos this is 3 cosine alpha, then this is S cosine alpha. Okay? Or if you don't want to memorize it, just copy it, no? This is H, this is S, delta H, S over cosine alpha. Okay? So we are given the value, H is equivalent to 3, alpha is 8 degrees. So calculate the rate of seepage through it in meter cube per hour per meter. So per meter ang mangyayari, we are going to consider 1 meter strip. Okay, 1 meter strip lang. Okay? So substituting, Q is equivalent to KIA. So that is the flow. Hinahanap kasi natin dito is flow per hour per meter. So Q is equivalent to KIA. K, we are given the value of K, which is 5.3 times 10 raised to negative 5 meter per second. Aalamin na lang natin yung value ni I. So for the value of I, take note, the hydraulic conductivity is delta H over L. Ito yung length natin. Okay? So that would be delta H over L. Delta H is S tangent alpha and L is S cosine theta. S will simply cancel out, cosine will go to the numerator. So tangent alpha times cosine alpha. So isimplify natin, tangent is sine alpha over cosine alpha. Cosine alpha and cosine alpha will simply cancel out and we are left with sine alpha. Therefore, I is sine alpha. Okay, so what is the area? The area is the height times the 1 meter strip. Okay, so that is 3 cosine alpha times 1. So that is 3 cosine alpha times 1. Okay, so substituting, we have K 5.3 times 10 raised to negative 5, then sine 8 degrees, 3 cosine 8 degrees, then dito naka seconds. To make it in R, multiply it by 3,000 seconds. Okay? So 1 hour is equivalent to 3,000 seconds. So the Q is equivalent to 0.0789 cubic meter per hour per meter. Okay? Next, paano naman pag ganito? So this time, you have a piezometer that is reading the piezometric reading. Okay? You have here H, which is a an impervious material, and H1 is a permeable layer. So, yan. Mas mataas ang pressure. Okay? So, H is 4 meter. The difference between the head is 4 meter. Then capital H is 8 meter. Capital H sub 1 is 3 meters. Then S is 4 meter. Then alpha is 8 degrees. K is 0.8 centimeter per second. So, the hydraulic gradient, ganun pa rin. Delta H over S or delta H over L. But this time, ang L na i-consider natin is the perpendicular distance. This is not a perpendicular distance. This is the perpendicular distance. So, that is S cosine alpha. S over cosine alpha. Okay? So, then for the area, it is this. H sub 1 times 1 meter. H sub 1 times it's not 1 meter. Pwede rin naman, per meter pala. Yeah, per meter yung ating kinocompute. But, if you want to determine the duration, ito, per meter, cubic meter per second per meter ang hinanap. So, it is a per meter length. Okay? So, Q is equivalent to Ki times A. So, that is K times I, this is I, times the area, H sub 1 times 1. That is, yung H natin? H sub 1, that is 3. So, 3 cosine 8. Substituting, K is 0.08 times 10 raised to negative 2. H is 4 cosine 8 degrees divided by the S, which is 50. Times 3, yung H sub 1 natin, 3 cosine 8 degrees times 1. Hindi na natin kailangan multiply ng 3,600 kasi it is in seconds. Kailangan natin in seconds. Yung kanina kasi ang kailangan natin is in meters. In hour, sorry. Okay? So the relationship for hydraulic conductivity and granular soil. So for fairly uniform sand, this is sand with small uniform coefficient, Hazen proposed an empirical relationship for hydraulic conductivity in the form of K is equivalent to C, D sub 10 squared, where C's constant varies from 1 to 1.5. D is the effective size in mm. So another form of equation that gives fairly good result in estimating the hydraulic conductivity of sandy soils is based from Kozeny-Kármán equation, which is K is equivalent to 1 divided by C sub S, S sub S squared, T squared, times unit weight of water divided by the viscosity of permeant, times the void ratio cube divided by 1 over E. For practical use, Carrier has modified equation 7.24. Ito yan. At 20 degrees Celsius, the unit weight of water divided by the viscosity for water is about 9.93 times 10 raised to negative 4 per centimeter second. So, he modified that and came up with this equation, where F sub I is fraction of particles between two sieves sizes in percent. So, combining equation 7.25, 26, 27, and 28, we came up with equation 7.25. The magnitude of the SF or the shape factor may vary from 6 to 8 depending on the angularity of soil particles. So Carrier further suggested a slight modification and came up with equation 7.26. 30. Okay, so let's try here an example. So we have here, and k, by the way, k is indirectly proportional to e cubed divided by 1 plus e. Then more recently, Choppius in 2004 proposed an empirical relationship for q in conjunction with equation 7.31, which is this. So k is equivalent to 2.4622 times quantity d sub 10, or the effective size squared, times e cubed divided by 1 plus e, quantity raised to 0.7825. Okay? So example 7.6. The hydraulic conductivity of a sand at a void ratio of 0.48 is 0.202 centimeter per second. Estimate the hydraulic conductivity at a void ratio of 0.6. So this is just a simple ratio and proportion. Okay? We're going to use equation 7.31. This is equation 7.31. So we have K1 is equivalent to E sub 1 cube plus 1 over E sub 1, E sub 1. Then K2 is equivalent to E sub 2 cube divided by 1 plus E sub 2. E sub 1, K sub 1 is 0.02, while we are looking for K sub 2. So that is unknown. So E sub 1 is 0.48 cube divided by 1 plus 0.48 divided by E sub 2 of 0.6 cube divided by 1 plus 0.6. Shift, solve. Therefore, your hydraulic conductivity at 0.6 void ratio is 0.036 centimeter per second. Next, example 7.7. The grain size distribution curve for a sand is shown. So this is the distribution curve. So plinat natin ito, sieve number and opening. Then we came up with this curve. Okay? So estimate the hydraulic conductivity using equation 7.30 given the void ratio of the sand is 0.6. Use Fs0, which is 7. Okay? So we skip that part. Medyo matrabaho yan. And the good thing about this is the situation gives you ample time, not just to memorize, but to look at the equation na. Kasi kahit sabihin natin na close notes, we do not have the way to check. So it is an indirect way of saying that it is an open note indeed. Okay? So for example 7.8, solve problem 7.7. This 7.7 using equation 7.32. So 7.32, this one. So copy that, paste it here. So D10 from the graph, is 0.09. Okay? D10, ito yung D10 natin. 'Di ba? From distribution curve natin, we've learned how to determine our D10, D30, and D60. So substituting 2.4622 times D10 of 0.09 squared times the void ratio of 0.6 cubed divided by 1 plus 0.6 quantity raised to 0.7825. Therefore, your K is 0.011 centimeter per second. I hope sinasabayan nyo kung isolve itong mga problems natin with calculators para mas nasusundan nyo. Okay? Next. Example 7.9 using 7.38. So from the graph, we were able to determine D60 at saka D10. Okay? So, this is our equation 7.34. So, kailangan natin ma-determine yung coefficient of uniformity. The coefficient of uniformity is D60 over D10. So, from the graph, you can get our D60 and our D10. Okay? So, our CU is equivalent to 1.78. So, substituting 35 times 0.6, ito yung void ratio natin, 0.6 cubed divided by 1 plus 0.6 times, what is CU? 1.78, 1.78 raised to 0.6 times D10, which is 0.09 raised to 2.32. Then, calculate. Therefore, the hydraulic conductivity using equation 7.34 is 0.025 centimeter per second. So, the relationship for hydraulic conductivity and cohesive soils. So, Kozeny-Kármán equation 7.24 has been used in the past to see if it will hold good for cohesive soil. Then, Olsen in 1961 conducted hydraulic conductivity test for sodium elite and compared the result with equation 7.24. This comparison is shown in figure 7.14. The marked degrees of variation between theoretical and experimental values arise from several factors, including the deviation from Darcy's law, high viscosity and pore water, and unequal pore size. So in 1948, Taylor proposed a linear relationship between the logarithm of K and void ratio. So ito yung kanya pre-propose na relationship, where K sub O is the in situ hydraulic conductivity. When we say in situ, it is the in-place hydraulic conductivity at a void ratio of E sub 0. K is the hydraulic conductivity at void ratio E. Kc is the hydraulic conductivity change index. So for a wide range of void ratio, Mesri and Olson in 1971 suggested the use of linear relationship between log of K and log of E. So log of K is equivalent to A prime log of void ratio plus B prime. So Samarashinghe et al. Conducted laboratory tests on new Liskeard clay and proposed that normally consolidated clays, K is equivalent to C times quantity E raised to N over 1 plus E, where C and N are constant. Okay. Okay, example 7.10. For a normally consolidated clay soils, the following values are given. 1.1 with a conductivity of hydraulic conductivity of 0.302 times 10 raised to negative 7 and void ratio of 0.9, which is 0.12 times 10 raised to negative 7. Estimate the hydraulic conductivity of clay at a void ratio of 0.75 using equation 7.38. So this is 7.38. So K is equivalent to C raised to E raised to N over 1 O plus E. So this is a simple ratio and proportion. So having these two values, input it in your equation. K, then E, then E. So you can observe that the unknown is the porosity. So further simplifying the equation, we can get N. And porosity is equivalent to 5.1. Okay. Dito kasi nag-cancel yung C. Okay? Don't get confused. Dito nag-cancel yung C. So having the value of n, we can now solve for the value of C. So substituting the void ratio of this 1.1 with the hydraulic conductivity of 0.302, we have C is equivalent to 0.39 times 10 raised to negative 7. So having said that, substitute it in your K, then we will be having 0.514 times 10 raised to negative 8. Example 7.1. A soft saturated clay has the following: percent less than 0.002 mm 32%, plasticity index 21, saturated unit weight 19.14, specific gravity of soil solids 2.27. Estimate the hydraulic conductivity of clay using use figure 7.18. Okay, so saan dyan yung 7.14? Figure 7.14. By the way, again, I repeat, the reference, our reference is the book of Braha and Das. Okay, figure 7.14. Nalagpasan. Ito. So, figure 7.14. So, using this figure, we have these values. Okay? So, the saturated unit weight, from there, we can determine our void ratio. So, for the saturated unit weight, it is specific gravity of the soil solids times the void ratio quantity times the unit weight divided by 1 plus E. Then substitute the value. We have our saturated unit weight, 19.4. Then a specific gravity of soil solids, which is 2.76. Then the unit weight of water, 9.81. Then we can have our E. E is 0.8. CF plus PI is CF is 0.32, PI is 0.21, CF plus PI is 53. So E is 0.8, CFPI 53. Okay. So the given here would be K and the porosity. So using the porosity, using the void ratio, we can solve for the porosity. No, that's 7.18. No. Sorry. It should be 7.18. Ayun. Kaya pala medyo nalilito tayo. Okay? So, the void ratio is 0.8. Tapos, ito, void ratio is 0.8. Tapos, our CF plus PI is 0.53. 0.53, so around here. Okay. So that is 0.8, 0.53. 0.8, 0.3. So magmi-meet siya around here. Then pag nag-meet siya dyan, connect it downwards. Okay? Therefore, the value is 3.59 times 10 raised to 8 using the graph. Okay? Lastly, the equivalent hydraulic conductivity in stratified soil. In a stratified soil deposits where the hydraulic conductivity for flow in a given direction changes from layer to layer, an equivalent hydraulic conductivity can be computed to simplify calculations. The following derivations relate to the equivalent hydraulic conductivities for flow in vertical and horizontal directions through the multi-layered soils with horizontal stratification. So when we say stratified soil, nag-iiba yung porosity per layer. So possible na nag-iiba yung soil type per layer. So dito, hindi lang iisa yung direction ng flow ng water. We have horizontal and we have vertical. Okay? So for the vertical, it would be K sub V sub N. For the horizontal, K sub H sub N. And you have here your total height. And you have the individual height of each layers of the soil. Okay? So for the horizontal, you have K sub H is equivalent to 1 over H times the quantity K sub H sub 1 times H sub 1 plus K sub H sub 2 plus H sub 2 up to K sub H sub N times H sub N, where V is the average velocity of the discharge. Okay, that this is for the horizontal. Horizontal, pag ganito, direction ng flow. Okay? So, for the figure shown in 7.22 shows and layers of soil flowing in a vertical direction. So, if it is flowing in a vertical direction, then therefore, there is a difference in head. Okay? Dito kasi wala tayong head difference kasi pare-parehas yung elevation. But for vertical, there will be a difference in head. So you have H1, H2, head 3. And you have the total head. You have here the height of the individual layers. And you have here the total height. And the direction of flow is vertical. Okay? So using Darcy's law, we can rewrite the equation where H is equivalent to H sub 1, H sub 2, H sub 3, hanggang up to head sub N. Okay? So for the vertical, we are given the equation as K vertical is equivalent to the total height divided by the individual height divided by the K sub V. Okay? So H divided by H sub 1 divided by K sub V sub 1 plus up to H sub N divided by K sub V sub N. Okay? So let's try here an example. So in example 7.12, a layer of soil is shown. Okay? So you have here H sub 1, H sub 2, H sub 3. K sub 1, K sub 2, K sub 3. So H sub 1, 1.5, H sub 2, 3 meters, H sub 3, 2 meters. K1, 1 times 10 raised to negative 4 centimeter or 10 times negative 4 centimeter per second. K sub 2, 3.2 times 10 raised to negative 2 per second. K sub 3, 4.1 times 10 raised to negative 5 centimeter per second. So this time, we are to determine the hydraulic conductivity. Estimate the ratio of the hydraulic conductivity. So the ratio is K sub H divided by K sub V. So we need to solve the K sub H and the K sub V. So for the K sub H, we simply copy this. Okay? Then solve. 1 over H. Ano yung total height natin? H1 plus H2 plus H3. 1.5 plus 3, 4.5, 5.5. Okay, so that's it. 1 over 1.5 plus 3 plus 2. Then, K sub H sub 1, or yung K1 natin, is times 10 raised to negative 4 times 10 raised to negative 4. The thickness is 1.5. Then, yung susunod naman is 3.2. 3.2 times 10 raised to negative 2. So, dito, K sub H sub 2, 3.2 times 10 raised to negative 2 times the thickness of 3 meters. Plus 4.1 times 10 raised to negative 5. Saan galing yan? Yan yung hydraulic conductivity ni 3. 4.1 times 10 raised to negative 5. Substituting times the thickness of 2. Then, input that into your calculator. The hydraulic conductivity horizontal is equivalent to 148.05 times 10 raised to negative 4 centimeter per second. The next thing that we need to solve is the vertical. So, for the vertical, we have this equation. So, ganun din. Kung dito, minultiply natin, dito, i-divide. So, the thickness divided by the hydraulic conductivity per layer. So, 1.5 plus 3 plus 2, this is the total thickness. The thickness of one layer, which is 1.5 divided by K1, H2 divided by K2, H3 divided by K3, and get the summation. So, input that in your calculator. The K vertical is 1.018 times 10 raised to negative 4 centimeter per second. To determine the ratio, divide KH. Anong KH natin? 148.05 times 10 raised to negative 4 divided by 1.1018 times 10 raised to negative 4. Therefore, the ratio is 145.4. Okay. Okay, example 7.13. So figure 7.25 shows 3 layers of soil in a tube 100 mm by 100 mm in cross section. So water is supplied to maintain a constant head of 300. So the hydraulic conductivity of soil, direction flowing through them are as follows. So this is A times 10 raised to negative 4, B is 3 times 10 raised to negative 3, C is 4.9 times 10 raised to negative 3. So ito yon. So each layer is 150 mm thick. Okay? So paano yung magiging flow ng water natin? So the flow of water would be from this point going to this point. Okay? Papunta dito. And we should maintain a constant head difference of 300 mm. So for this one, ang gagamitin natin, do you think it is horizontal or the vertical? Yung horizontal, iisa lang. The flow is one direction. Iisang medium lang. So if it will pass 3 media, we have one, isang media lang. If it will pass 3 medium, pag ganyan, then, therefore, we are going to use the vertical hydraulic conductivity. Okay? So, copy this equation. And we will be using that equation for this. Okay? So kV is equivalent to H. Ano yung total H? 150, 150, 150. So that's 450 mm. 450 mm. Okay, so first we have 150 divided by times 10 raised to negative 2. So 150 divided by times 10 raised to negative 2. Next, we have times 3 raised to negative 3 times 10 raised to negative 3. The thickness is 150. So 150 divided by 3 times 10 raised to negative 3 plus 150 again divided by 4.9 times 10 raised to negative 4. Then calculate, the answer should be 0.001213 centimeter per second. Okay? Then we can now solve for the flow. Flow is equivalent to K times I times A. This time, ang K na gagamitin natin is K vertical. So, yung hydraulic gradient natin, it is the change divided by the L. Diba? Yung yung I na hydraulic gradient. So, the hydraulic gradient is the change. So, that is 300 divided by the total length of 450. So, 300 divided by 450 times the area. Okay? So, what is our area? Okay. So, for the area, it is 100 mm times 100 mm. So, the cross-sectional area of these soils are 100 mm by 100 mm. But take note, ang pinag-uusapan natin dito is in centimeter. So, yung 100 mm gagawin nating centimeter, so divided by 10 times the another dimension of 100 mm. So, gawin nating centimeter. So, centimeter times centimeter. Calculate. Therefore, ang lalabas is 0.0809 centimeter per second. But, ang hinahanap sa atin, in hour. So, convert it in hour. So, 3,600 seconds is equivalent to 1 hour. So, multiply 0.0809 by 3,600 seconds. Therefore, ang magiging sagot natin is 291.24 centimeter cube per hour. Okay? So, the permeability test in field by pumping from wells. So, in the field, the average hydraulic conductivity of soil deposits in the direction of flow can be determined by performing the pumping test from wells. Figure 7.26. 7.26, ito yun. Okay. Shows a case where the top permeable layer, whose hydraulic conductivity has to be determined, is unconfined and underlain by impermeable layer. So, it is unconfined and underlain by an impermeable layer. So, meron tayo ditong impermeable layer. So, it is confined. Okay? Unconfined. Then, during the test, water is pumped out at a constant rate from the test well that has perforated casing. Several observation wells at various radical distances are made around the test wells. Continuous observations of the water level in the test well and in the observation wells are made after the start of pumping until a steady state is reached. Okay, the expression for the rate of flow of groundwater into the well, which is equal to the rate of discharge from pumping, can be written as Q is equivalent to K times the change in H with respect to the change in the radius times 2 pi r H. Next, for in the field, an average hydraulic conductivity of soils deposit from direction of flow can be determined by performing test wells. Figure 17.26 show a case where top no, nagkamali. It is the same. So Q sorry, parehas lang siya, no? So you have here Q is equivalent to K times the change in H with respect to the change in radius times 2 pi RH. So cross multiply. So the change in R with respect to R is equivalent to 2 pi K over Q, and the integral of H dH from H1 to HQ is also equivalent to the integral of dr over R from R1 to R2. Okay, so this is H1 to H2, the change in H1 to H2. So this is your well. Ito yung well natin. So itetest, we are to draw water. So pag nagdo-draw tayo ng water dito sa ating mga wells, no? And ito yung ating water table before pumping. Of course, magdi-decrease yan. And this would be the shape. Okay? This is radius 1, well 1, and this is radius 2, which is well number 2. So the H1 is the height of the water level before pumping out water. H2 is after pumping. Okay? So for that, ang gagamitin natin is K is equivalent to 2.303 Q log base 10 R1 over R2 divided by 14.75 H sub 1 squared minus H sub 2 squared, where Q is in gallons per minute. Gallons per minute. H1 and H2 are in feet. If, ganito naman, kanina, we have an impermeable layer. But if we have a permeable layer, ito yung, kasi kanina, nag-stop tayo dito and nandun na yung ating water table. But this time, we have a confined aquifer. Then, sa ilalim yung confined aquifer, nandun yung impermeable layer. Therefore, ang gagamitin nating equation would be this. K is equivalent to Q log base of 10 R1 over R2 divided by 2.727 H1 minus H2. I repeat, this is for wells which have a confined aquifer underlain by an impermeable layer. Okay? Nasusundan ba? So this is our piezometric level before pumping out water, and pag nagpump na ng water, this is the change in H. Okay? So that sums up our discussion for permeability. If you have any question, just comment down below kung saan ko ipopost yung link ng video na to sa ating group page. Okay?